Hello, Mr. Biscup and Mr. Biscup's class. My name is Brody Knapp. I'm here with Hunter Crane, Will Mayfield, Tyler Malin, and Craig Adams. Today we're going to be talking to you guys about Mississippi State's mechanical engineering program. So first off, who are we? As I said, my name is Brody. I'm going to graduate with a bachelor's in mechanical engineering and a minor in math. I'm a West Forsyth alum. I'm very passionate about hands-on engineering, and I have some background in maintenance and reliability engineering, SolidWorks design, and project engineering. And I've recently accepted a full-time offer from Ketchen Corporation, which is a catalyst solutions company in the petrochemical field.
My name is Craig Adams. I'm also graduating with a bachelor's in mechanical engineering and a minor in math. I'm interested in providing clean, reliable power to my community. I have a background as a reliability engineer through my internship at Arkansas Electric Cooperative Corporation, and I'm committed to ensuring consistent power generation. And I'm now going to be pursuing a career with Arkansas Electric Cooperative Corporation.
Hey, my name is Will Mayfield, and I'm a senior graduating with a bachelor's degree in engineering. My dreams are simply, I just want to make the world a better place in any way possible. As a background, I've been an undergraduate researcher for just under a year now. My focus has been in wind energy and tidal energy, along with AI implementation into energy systems, and also AI implementation for automated grading assignments. I have dreams of pursuing a PhD here at Mississippi State in pursuit of becoming a research and development engineer.
Hello, everyone. I'm Hunter. I'm graduating with a bachelor's in mechanical engineering and a minor in math, like my fellow other teammates. So I'm passionate about saving lives and helping people out as I can as an engineer. I have a background in mechanical design, engineering at Northrop Grumman, and a system safety, range safety internship as well. So now I'm pursuing a full career with Northrop Grumman as well.
Hey y'all, my name is Tyler Malin. I will also be graduating with a mechanical engineering degree with a minor in mathematics. I'm driven to protect the lives through innovation one design at a time. My background includes an internship with NASA, where I was a test engineer, where I did a lot of testing on wind tunnels. I will be pursuing a career at Northrop Grumman, which is a defense contracting company, where I'll be working on submarines when I graduate. So why are we presenting to y'all? We want to inform the public about mechanical engineering. We also want to let y'all know a little bit about what we did for our senior design project. And we also want to give y'all insight into what mechanical engineering students can expect at Mississippi State and the possibilities that arise from being a student here. So what is mechanical engineering? It's the broadest engineering profession. Mechanical engineers are crucial for technological advancements. Every project, every design is going to need a mechanical engineer to help out. Mechanical engineers design, develop new machines, devices, and systems, which is going to drive technological advancements. They are needed to build infrastructure that includes roadways, buildings. They also play a crucial part in renewable energy technology, and also mechanical engineers were needed to design vehicles, household appliances, medical devices, robotics, really everyday life applications. You're going to need a mechanical engineer to design and develop these things. So what is there to do with mechanical engineering? Well, specifically, it's going to focus on designing and CAD work, but there's also a lot of subcategories like manufacturing, robotics, which I know Brody told us that y'all love robotics. That is something that Mississippi State does offer. We have robotics classes available and a lab specialized for robotics. Testing, which is what I'm going into. We have maintenance, which is what Brody Knapp's going to be going into, and also energy system, which my fellow Will is going to be going into. How is it applicable? Well, using the information we learn in our coursework, people can bring insight into solving problems. You start to learn to communicate as an engineer and think like an engineer. And a life-changing story is Nicholas Otto. He was the inventor of the four-stroke Otto cycle, which is used in engines that we see in our vehicles that we use every day.
So what are we doing? This semester, we were tasked with designing and constructing an H-type vertical axis wind turbine prototype. Our objectives were to build one that was capable of producing 300 watt hours of power for any given wind direction or condition. Our main goal was, however, to determine if small-scale vertical axis wind turbine energy is a clean, reliable source. So a little about our design. Our design is what's known as a lift-based wind turbine as opposed to a drag-based. These are omnidirectional, meaning that they can generate power from any given wind direction. When with the wind rotating the shaft due to lift forces, the shaft is directly connected to the generator for power generation. In our case, we used a three-phase AC PMG or permanent magnet generator for power generation.
Okay, so for our airfoils, they're centered around a 6-foot long aluminum H-beam, and there's 10 NACA 18 aluminum airfoil profiles that are secured to the H-beam using 3D printed brackets. There's also 3D printed brackets on the front and end of the airfoil so it can maintain its shape once it's wrapped in sailcloth, which y'all will see in a minute. For the bottom portion of the support structure, there are 3 base plates that go on the bottom that are bolted to the ground through the holes in the corner. Then there are 3 legs in a tripod configuration that are angled at 70 degrees and attach the bottom support plates to the mid base. And those legs are connected to the mid base and the bottom base plates through custom brackets. Then for the airfoil shaft connection structure, there is a 6-foot long rotary shaft, 1-inch diameter in the center. And then there are 2 circular flanges that are welded to that rotating shaft. And then from those flanges, support arms come out at a 45-degree angle and are bolted to the top and bottom of the airfoils using custom brackets. There's also the bearing housing that the rotary shaft goes through, and it's connected to the rotary shaft using clamping shaft collars. Inside that bearing housing, there's radial and thrust bearings, so our shaft can rotate freely without vibrations.
So how do we manufacture this? First, we have a Cavs lab here that is able to water jet parts out. And so we water jet the airfoil profiles, as you can see here on the left, and those profiles are able to slide through an H-beam. As you can see the letter H in those profiles, those will slide through the H-beam. And the H-beam is in the picture in the middle, and we drilled through the H-beam so that we can use those 3D printed brackets and attach the profiles to that beam. And then for the H-beam to attach to the support arms, we made these brackets on the right that we tapped holes and we're able to connect them to the support structure. So after we created the skeleton of the airfoil, we then wrapped it in a sailcloth material. We first grommeted holes in the sailcloth material and then was able to bolt it to the airfoil structure itself. We then glued the ends, as you can see on the right, and let it dry overnight, and we had our completed airfoils. So next, we tackled the base, and we welded the base together. So as a tripod configuration, we welded those base plates, which are able to bolt into the ground, to the legs, which are then welded to a mid base, and that mid base has that bearing housing tube on top. So the complete vertical axis wind turbine, after putting everything together, looks as follows on the left. It is 9 foot tall, weighs 230 pounds, and has a rotating diameter of 6 feet. You can see us on the right. This is us in front of the turbine. It is very big, and it was very fun to put together. We had a great time building it. And for testing, in the next slide, you can see me using 2 leaf blowers, blowing the turbine to see if it self-start, and it does have self-start capabilities. So what does the vertical axis wind turbine help? This turbine allows for future research of these in rural areas on a smaller power grid. The hope is to be able to put these in areas where the power grid is already small and homes struggle to get electricity sometimes. So these turbines can be put straight into homes, and if the home has more energy than it needs, it can then be put back into the power grid as well.
So, why Mississippi State? Well, at Mississippi State, you get a fantastic education. It is a top 100 engineering school. with over 30 industrial partnerships. So what this means is that throughout your time here, you're going to be involved in several projects, which are going to be funded by typically these industrial partnerships. You get hands-on experience in about every field of mechanical that you could imagine in some way, shape, or form, whether that's through labs or projects or group work presentations. Um, Additionally, there's a 98% job placement rate after 3 months at post-graduation. This is excellent. It's very reflective of the quality of the education that you get here in Starkville. Continuing on, here you can see a couple of the pictures of the state-of-the-art IDE lab that we have recently built here. On the left side of the room, you can see all of the CNC machines that we have. There's a water jet down there. The welders are in the back room, and there's just countless machines there that you can get in there and get hands-on experience with and learn how to operate them. On the right, you can see all the manual machines. So this is going to include your mills and your lathes and whatnot. So since you have access to all of these machines, you can make pretty much anything that you desire, given that you have proper funding. So the possibilities are endless here at Mississippi State. So here is a rough outline of the curriculum at Mississippi State, just to give a general understanding of what you'll be learning. It covers a very broad field of subjects, as is the essence of mechanical engineering. A couple ones to highlight, though, that I really enjoyed and that I think relate to you guys. You get a lot of experience in machine design and CAD work. I know Mr. Biscup is a huge fan of SolidWorks, so you will further expand on that experience in school here. Additionally, I know you guys like a lot of robotics. So you get some experience in circuits and programming, which is a further expansion on what you guys are passionate about in high school right now. Outside of your core curriculum, there is a vast choice of technical electives that might pertain to your personal interests a little bit more. When I came to school, I was very excited about getting into automotive experience and stuff like that. But as I went through my time here, my interest shifted to something more along the lines of energy systems. So your interests are reflected in these technical electives. So that opportunity is there for you guys. So in conclusion, mechanical engineers drive the future of the world. They're involved in everything due to the broad application of what you'll learn. And Mississippi State does a fantastic job at preparing engineers for the future and ensuring that you will be an excellent engineer once you graduate. So yes, thank you guys for hearing us out. Thank you, Mr. Biscup, for giving us this opportunity. If you guys have any questions, hopefully Mr. Biscup can collect those and send them over to me. So yes, consider applying to Mississippi State and stick to engineering.